Okay, I'm going to go over the 4.5 homework. Starting with numbers 1 through 5, and then 9, 11, 13, 17, and 20. The picture statement below represents the ASA triangle congruence conjecture. Explain what the picture statement means. If you know this, then you know this. Well, if you know that, of course, the angle and a side and an angle, and the angle, a side, and an angle of two triangles are congruent, so the angle and included side and an angle, then you know the two triangles are congruent, meaning all the corresponding angles and all the corresponding sides are congruent. Number 2, what does this mean? Create a picture statement that represents SAA. Explain what the picture statement means. Okay. SAA means that if two angles and a non-included side of one triangle are congruent to the corresponding side and angle of another triangle, and the triangles are congruent. So these are actually switched, by the way, in the answer key for some reason. It should be if you know that you have an angle, a side, and an angle that is congruent to a corresponding angle, side, angle. Make sure you have corresponding in there. Then the two triangles are congruent. All the corresponding sides and all the corresponding angles are congruent. Number 3, in the second investigation, you discovered that the AAA case is not a triangle congruent shortcut. Sketch a counterexample and explain why this is not a shortcut. Well, here we have two triangles that have the same angles, but they're different sizes, so they're clearly not congruent to each other. Next is 4 and 5. Determine whether the triangles are congruent and name the congruent shortcut if the triangles cannot be drawn to be congruent. Right cannot be determined. In 4, the answer is ASA. Well, why is that? Well, here we have a side that's congruent to a side. And then we have an angle congruent to an angle. And these are vertical angles, so these are also congruent to each other. So that's going to be ASA, angle, side, angle. To review, is this side an included side or a non-included side? It's in between two angles, so it's an included side. Cannot be determined. Well, let's see what's going on here. We have a side congruent to each other, and then this side's congruent to itself, and then the angle. So that is SSA. Is that a congruent shortcut? No, that is not. And so you'd say cannot be determined. Cannot be determined would be your answer for number 5. Next, we'll do 9, 11, 13. Number 9, here we go. Is triangle ALT congruent to triangle INT? ALT and INT, well, let's see here. So we know these angles are congruent to each other. And alternate interior angles are congruent. So this angle congruent to this angle. And this angle congruent to this angle. Do we have any congruent sides? No. So this is just angle, angle, angle. Is that a congruent shortcut? No. So it cannot be determined. And next is 11 and then 13. Okay, so 11. In exercises 10 through 17, if possible, name a triangle congruent to the triangle given and state the congruence conjecture. If you cannot show any triangles to be congruent from the given information, write cannot be determined and explain why. Okay. So OH is parallel to AT. So let's go ahead and mark that parallel here. Okay. So again, that's going to mean that alternate interior angles are congruent to each other. So let's mark that. Same here. Okay. And then, oh, look at that. These are vertical angles. So these are congruent. All the angles are congruent, and we have a congruent side. So looks like we're going to have ASA, angle, side, angle, or AAS. That would also work. Two possibilities. Now we need to list out which triangles are congruent. Does the order matter? Absolutely it does. So if we start with W, well, W, we need to start with W here. So that W, these need to match. Okay. Then H, what angle matches H? Well, T. So the next letter here is T. And then about O. What angle matches O? Well, there's two dashes in A. So O would match A. So make sure that the order shows which angles correspond and be congruent to each other. Next is number 13. Okay, let's see what we're given here. PO equals PR. PO equals PR. Angle O congruent to angle R, that's marked. Angle OPE and NPR are right angles, also marked. What is triangle POE congruent to? Let's see here. Looks like we have angle, side, angle, ASA. So P, oh, interesting. Looks like we have another typo. I think that should say triangle POE. It's like someone was tired when they did this. Okay, so again, all the corresponding angles should match up. So if we start with P, and start with this vertex, that vertex matches up. So we're going to start with P over here. Next, I go to O. So what angle lines up with O? Well, that would be R. So the next letter would be R. And then, of course, N. So PRN, triangle PRN by ASA. Alrighty, next is 17 and then 20. Okay. So triangle LAW is congruent to what triangle? Let's see here. LAW. WKL. Well, it looks like we have a right angle, another angle, and this side's congruent to itself. So that's going to be angle, side, angle. Side is included. It's an included side between two angles. So notice, let's see, what order are we going to write this in? Well, L corresponds to W. W is the right angle over here. The next is A, and A is going to correspond to K. And then W corresponds to L. There we go. Very good. Okay. WKL. Beautiful. Okay, so that is again by ASA, angle, side, angle. Next is going to be number 20, finally. Number 20. Okay. Use a compass or patty paper and a straight edge to perform each construction. Draw a triangle. Use the ASA congruence conjecture to construct a second triangle congruent to the first and write a paragraph to justify your steps. Okay, so what they're showing you here is you're gonna draw a random triangle. Let's ink to shape. So you draw a random triangle. A little better here. Okay. You're going to then duplicate that triangle using angle, side, angle. So I'll just draw a really long line. And then you're going to, with a compass, put one end here and the other end here. And then duplicate that. And it'll be about, you throw an arc right here. And that would be your second point. And then what you're going to do is duplicate, call this A, B, and C. Duplicate angle A. You swing an arc, swing the same arc, and swing an arc here and an arc here, and you throw a line through that. You do the same thing where you duplicate angle B, and that's what they're showing you right here, where you swing that arc there and that arc, and you're duplicating it on there. And so you're duplicating a side, and then an angle, and then an angle. And that's why you're using ASA to duplicate that triangle, because you know it'll be the same as the original triangle. Okay. If you need more help with this, you can go to Math Open Ref website. Just Google Math Open Ref Constructions, look under triangles, and look for ASA. And that will walk you through how to do an ASA duplication. And in fact, I probably have time in this video to do that.